Hello, my name is Anthony Bryant, and this is EDMU 525 T Science Plate Tectonics. But before we get into plate tectonics, let's do a quick review and talk about the structure of the Earth. The Earth is made up of three main layers: the mantle, the core, and the crust. The crust. The Earth has two different types of crust: the continental crust and the oceanic crust. Each has different properties and therefore behaves in different ways. The continental crust forms the land that we see today. The continental crust averages about 35 kilometers thick. Under some mountain chains, the crust thickness is approximately twice that amount, so it's about 70 kilometers thick. The mountains we see on Earth have deep roots in the crust that we can't see. The crust floats on a denser mantle. Example, we're going to picture an iceberg sticking out of the water. You see only the tip of the iceberg, but the mass underneath the water is much thicker. The same thing with the continental crust. We see the mountain ranges, so the part that we can see is a lot thicker than what's sticking out of the ground. The continental crust is less dense and therefore more buoyant than the oceanic crust. The continental crust contains some of the oldest rocks on Earth. The oceanic crust is thin. It's approximately 7 kilometers. It's dense. It sinks underneath the continental crust and is rather young. And we're going to take a quick picture. Look at the picture that I have here. And that's the continental crust and the oceanic crust. Here we're taking a look at the mantle. This is the layer of Earth between the crust and the core. It contains most of the Earth's mass, has more magnesium and less aluminum silicon than the crust. It's denser than the crust as well. Now we take a look at the core. It's below the mantle and to the center of the Earth. It's believed to be mostly iron, small amounts of nickel, almost no oxygen, silicon, aluminum, and maybe some magnesium. So what is plate tectonics? It's a theory explaining the structure of the Earth's crust and many associated events as resulting from the interaction of rigid lithosphere plates that move slowly over the underlying mantle. Plate tectonics is the Earth's crust is divided into 12 major plates, which all move in various directions. The plate motion causes them to collide, pull apart, or scrape against each other. Each type of interaction causes a set of Earth structures or tectonic features. The word tectonic refers to the deformation of the crust as a consequence of plate interaction. So here is a diagram that shows the major plate tectonics. As we can take a look between some of the boundaries of Africa and South America, we see that the boundary here looks like it's cut out, like we said, like puzzle pieces, like they should fit into each other. That's why the theory is that all the landmass were together, and because of this shift, this plate tectonic, caused all the landmass to spread apart. So what are the tectonic plates made of? Of course, they are made up of plates are made of rigid lithosphere. The lithosphere is made up of the crust and the upper part of the mantle. As we talked about earlier in our review, we know that the Earth is made up of crust, mantle, and also a core. So this is just to break down more of what things are made out of. The plate tectonics are made out of. What lies beneath the tectonic plates? Below the lithosphere, which makes up the tectonic plate, is the asthenosphere. The asthenosphere beneath that is part of the upper mantle, and it's so hot that it is about 5% liquid and 99% solid. This liquid usually at the junction of the crystals allows it to flow, which is why astheno means weak. Beneath the asthenosphere is the rest of the mantle, which is completely solid, but can also flow on a geological time scale because of the tense pressures that's involved with some of the things that's going on. And again, here's a picture of some of the plate movement. You see that you have trenches and ridges, and we're going to talk about the movement a little bit more here. We have divergent movement. We have which the plates move apart. We have convergent movement, which means that the plates come together towards each other, and then the transformation boundaries where the plates slide past each other. So again, that is the divergent boundaries where the plates move away from each other, the convergent where they move towards each other, and then the transform boundaries where their plates slide past each other. And here's another picture of those plates and how they're spreading. And again, the continental crust, how it is in the lithosphere. A little bit more pictures here just to clarify some of the explanations. So we take a look at one of the transform boundaries here, and we see a nice little gap here where the two uh, faults had, when they slide past each other, you see that the land has got like a ridge line started up. This is kind of like an example of the Andreas faults, the San Andreas fault. It's kind of close, adjacent to San Francisco. So in our plate summary here, we're going to say that the Earth is made up of three main layers. We're going to summarize that. On the Earth's surface, the Earth tectonic plates that move slowly around the globe. The plates are made up of crust and upper mantle, the lithosphere. And we discussed that there were two types of plates, and we also talked about the three types of boundaries. And we know that because of plate tectonics, it has a lot to do with volcanoes and earthquakes, and we'll talk about that a little bit more in our next session. All right, have a nice day. Thank you for listening.